All right, my 130s. So I'm going to go over the rest of this guide. This is my writing utensil. Chapter 5, homework alternate assignment. So I'm going to attempt to get through number 32 to 45. I might pick a few select ones and just go from there. But I will work as many of them out as I can. All right, so let me go ahead and clear that. So let me start with number 32. Again, we have a complex fraction here. Okay, we have essentially this numerator that can be simplified and the denominator can be simplified. So still going to color code here. Blue for the complex numerator. Orange for the complex denominator. So we need to find the LCD for the top, in blue, and the orange on the bottom separately. So LCD for this top portion is the factor u minus 3 times the factor u plus 5. And in this case, you actually get the same LCD for the denominator of the complex fraction. Okay. So when you're working through the problem, leave LCD in denominators factored. Okay. Don't distribute out. Okay, so don't actually find what this is by distribution, just leave it factored. Okay, so for the numerator, that'll be in blue. We have 3 times u minus 3, the fraction already. We're going to be multiplying that by u plus 5 over u plus 5. And then for the second part, we have 1 over u plus 5. We're going to be multiplying that by u minus 3 over u minus 3. Okay. I would have actually written it like this as my first step. But just in case you're used to the old, have a fraction and then how do we change it? I decided to do it that way first. So I'm going to go ahead and delete this line. And then I'm going to move this bit up. Okay. So that's the first bit. Make your big fraction bar. And then the denominator of the complex fraction, we're going to work similarly. So 6 is missing the u plus 5 from the denominator. Let's multiply that u plus 5 top bottom. We have subtraction 2, we're missing u minus 3 top bottom. Okay. Then remember in the next step what happens. On the top, we can combine the fraction into 1. Okay, on the bottom, same thing. Okay. Second, I gotta pop up here. Okay. All right. So next, we're gonna go ahead and distribute and simplify the numerators of our fractions. So this part here and this part here. All right. So we have on the top part here, 3u plus 15 plus u minus 3 all over u plus 5, u minus 3. And then that's divided by 6u plus 30 minus 2u plus 6 divided by u plus 5, u minus 3. Now, do review the last video. I discussed why in this next step you can actually just go ahead and cancel the u plus 5, u minus 3 with u plus 5, u minus 3 right here. Okay. But for now, actually, I'm going to go ahead and do that. Let me put a little side note here. The reason I have this stuff up here which we could actually go ahead and combine, but I'm just going to wait on it so I don't have to keep writing out the denominators. We have this. Old school division with this. Okay, and then we keep this first fraction here. And remember, we flip the second fraction. So that's why these guys cancel out here. Okay. So then what we're left with is 3u plus 15 plus u minus 3 divided by 6u plus 30 minus 2u plus 6. All right, let me save that, and then I'm going to delete this stuff on top so that I have some more room. Definitely give yourself lots of space on your papers when you are completing these problems. Okay, select this and move on up. Okay, so let's continue. So we have 4u plus 12 from the top. And on the bottom, we have 4u plus 36. Okay, so careful here. I'm gonna write over here, don't. Go, okay, 4u plus 12 over 4u plus 36. I can cancel that out and change that into u. Oh, actually, I can just change that into 1 because the 4u cancels with 4u. And then over here, okay, 12 goes into 12 once and into 36 3 times. So I get a 2/4, which is 1/2. Okay, that's incorrect. You must factor first. Okay. So let me clear this nonsense out here. Okay, so then let's factor the top out. We're going to factor out a 4. And we're left with u plus 3. On the bottom, we factor out a 4, and we're left with u plus 9. So 4 cancels. And our final answer is u plus 3 over u plus 9. Okay. All right, so save this. I'm going to clear it out, move on to the next one. Next one's number 33. I'm going to move it down here. So for this one, you're going to have to change these negative exponents into positive ones, and you need to do that remembering that you can make fractions out of this. So 1 second, let me actually just do side note. So recall that if you have a to the negative n, whatever, that's fine. That's the same thing as a over 1 to the negative n. If you want to change the exponent into a positive, you flip the numerator and denominator inside the fraction. And then you'd have 1 to the n power over a to the n power, just 1 over a to the n. So in this case, you have b to the negative 2. That's b over 1 to the negative 2. 1 over b squared. 1 squared over b squared, which is 1 over v squared. Okay. Now, of course, you could just shortcut that. If you already know that this part leads here, it's okay to write that. All right, let me save and then clear that out. So here, we're going to have 1 divided by 1 over v squared plus 1 over u squared. All right, so now keep the 1 on top for the complex fraction. For the bottom part, find the LCD. In this case, it's v squared u squared. So we're going to have v squared u squared plus v squared u squared, and then missing factor, missing factor. Okay, so now we can combine. So much noise in the background. Okay, so now here, this is important. you need to remember that this 1 can actually be written as 1 over 1. Okay, let me save this, clear out the top. So here we have a fraction over a fraction. So we can rewrite that. So 1 fraction divided by 1 fraction. We're going to write 1 over 1 divided by u squared plus v squared over v squared u squared. Gee whizzo. I live by an alleyway and there is a trash truck in the background. Sorry if you can hear it. Okay, so now we have 1, okay, goodness gracious, and this pen is killing me. All right, here we go, 1 over 1 times reciprocal of the second fraction and then you just multiply straight across. That gives you v squared, u squared, divided by u squared plus v squared. Okay, let me save that, clear it out. Number 34 is next. So now we get to solving equations using rational expressions. We're just solving rational equations. Okay. For these ones, I want to emphasize must check your answers in original equation. We'll see where this comes into play a little bit later. Okay, so let's go ahead and start number 34 down here. I will definitely need some more space. So first thing, you want to get a common denominator. That's one way actually. Remember, you can multiply your entire equation by the LCD as well, and it works out just fine. So let's first find the LCD. Over here. LCD is 21 W squared. So let's do method 1, method 2. Combine fractions on left-hand side, then solve. So if you were doing that, you'd say, okay, I have 2 over 7W, and I'm going to be multiplying that by 3W over 3W. And I have 5 over 3W. Multiply that by 7W over 7W. And just keep the 1 on the other side as it is. So then the left side becomes 6W over 21W squared plus 35W over 21W squared. That equals 1. These are like terms. If you can't see it yet, just combine here. So then from here, we have 41W over 21W squared equals 1. Okay, let me save this, clear out the top. Okay, select all this. Okay. So then from here, what you would do, you would multiply both sides of your equation by the denominator, 21W squared, so that you can get rid of it on the left side. So now you have 41W equals 21W squared. You're solving for W, so be careful. You actually don't want to divide out a W, or you're dividing out a solution. Instead, what you're going to want to do, get all your terms, your W terms on one side and factor out. So I'm going to subtract 41W, both sides. 0 equals 21W squared minus 41W. I get 0 equals W times 21W minus 41. Okay. And then from here, I actually get two solutions using zero product property. Let me see. Here at the top. Okay, come on, man. Like sometimes the select thing can be very finicky. Okay, you know what? Forget this. Let me redraw. We had 0 equals W times 21W minus 41. Okay, so zero product property states that if two factors are multiplied and equal to 0, each one of those factors can individually equal 0. So if A times B equals 0, then A can be 0 or B can be 0. So in our case up here, we have W equals 0 or 21W minus 41 equals 0. So this would technically be a solution. And then solve for W over here. We have 21W equals 41. And then W equals 41 over 21. Now you have to check. So note, if I check when W equals 0, I would get 2 divided by 0 plus 5 divided by 0 equals 1. And that's a problem because we would have an undefined value. Okay, remember 0 in denominator, undefined. So W equals 0 is not a solution. Okay. Now, similarly, when you check, you can actually plug your W value into here. I would suggest using a calculator for this kind of check. Let me clear all this out. Okay, so next check. W equals 41 over 21. Check it in the original. Check your solution in the original equation. You could use a calculator for this. If you get confused about that, let me know. This is going to be 2. I'll just do it faster. 7. Oops. Okay, hold on. Okay, so that was the long way. You would not have to do that. You can use your calculator for it. Let me know if you need help maneuvering through that. All right, let me clear my screen. And then method 2, I'll just get you set up with, but I'm not going to do the whole thing for time purposes. Okay, so that would be to multiply entire equation by the LCD. Remember, in this case, the LCD is 21W squared. So I'm going to take 21W squared and multiply that to each term. In my entire equation. Okay, so what happens here, just in case you need to see one more step, we're going to have 21 w squared times 2 divided by 7w squared divided by 7w, and then plus 21w squared times 5 divided by 3w, and that's going to equal 21w squared. Okay, so notice what cancels. 21 divided 7 is 3. And then w squared divide w, there's just 1w on top. So we get 3w times 2 plus over here, get 7w times 5. That equals 21w squared. And that's 6w plus 35w equals 21w squared. 41w equals 21w squared. And then factor, use zero product property. You should get the same thing. All right, let me clear this out. The next one I'm going to do, I'll do number 35, that's fine. Okay, number 35, I'm going to speed up a little bit for this one. LCD, you have this first bit, which factors down to 2 times u plus 5. You have 1, that's divided by 1. And you have u plus 5 over here. So between 2u plus 5 and u plus 5, essentially, you need the factor of 2 and just 1 of the u plus 5s. Okay, so I'm going to do the multiply LCD to entire equation just to get rid of the fractions. I have 5 over 2 times u plus 5 plus 1 equals negative 8 over u plus 5 right now. So I'm going to multiply by 2u plus 5, 2u plus 5, and 2u plus 5. Okay, see what cancels. 2 cancels 2, u plus 5 cancels u plus 5. We're left with 5 in the first term. For the next one, nothing cancels. You will multiply straight across. You have 2 times the quantity plus 5. And then over here, u plus 5 cancels with u plus 5. You have 2 times negative 8 left over. So that's 5 plus distribute 2u plus 10 equals negative 16. 15 plus 2u equals negative 16. Subtract 15 both sides. 2u equals negative 31. And divide by 2. U equals negative 31 over 2. When you check it, it actually does check out. Okay, save that, clear that out. Let's go with let's do number 36. And then I'm going to skip a few of these since they're very similar for 37, 38. I'm going to go to 39 after this. Okay, so for question 36, again, we're going to find our LCD. We need to factor down. Okay, here we have a u minus 3. Here, this is a difference of square. It factors into u plus 3, u minus 3. And then here we have u plus 3. So let's write our LCD up here. LCD is going to be, so we have a u minus 3 that's located in 2 of the denominators, but not the third one. So we're going to use one of those as a repeat factor. Then we have u plus 3 that repeats once, but is still missing from one of the fractions. And then that's all we need. Okay. All right, now here in the next step, multiply your entire equation by your LCD. I'm going to do it separately. If you're comfortable distributing straight into, you can do that. I'm just going to show it, even though it takes a little bit longer, so you can actually see the cancellations. Okay, hopefully that's clear. Okay, so what cancels? U minus 3, the factor, cancels u minus 3, the factor. You're left with 4 times u plus 3. Next, we have u plus 3 canceling with factor u plus 3. U minus 3 canceling with factor u minus 3. So we're left with plus 6. And then lastly, u plus 3, the factor, cancels u plus 3, the factor. We're left with 1 times u minus 3. Distribute 4u plus 12 plus 6 equals u minus 3. And then solve for u traditionally. 4u plus 18 equals u minus 3. All u's one side. All constants other side. Divide your 3 out. U is negative 7. And then remember, you need to check. And this one checks out. Okay, so far so good. I'm going to move to question 39 now. Okay, so question 39, we are solving for B. So we essentially need to undo the steps to get to B. Remember, we're treating K, P, and A as if they're constants. Okay, so my first step, I'm going to note that I could multiply both sides by 6 to get B. Well, to get one step closer to B, I should say. So 6 cancels out. I have 6K on the left side, and I have P times the quantity A minus B on the right side. Continuing to solve for B, you're going to be tempted to distribute the P out. Well, actually, you could. So from here, 2 ways. You have 6K equals distribute. You have PA minus PB. Then I would subtract PA from both sides. I have 6K minus PA equals negative PB. And then I divide out both sides by negative P. So B is equal to 6K minus PA over negative P. Which is also the same as saying 6K over negative P plus A. Okay, remember you can separate. Maybe I should take it back one more step. So 6K divided by negative P. And then you have minus over minus, which becomes a plus. You have PA over A, or PA over P. That was terrible. So let me actually just do this. Let me leave it in this form for right now. And then let's look at the second way. For this way, I'm going to divide P out first. Okay. So then I have 6K over P equals A minus B. You can drop the parentheses once it's the only factor by itself. Then I'm going to subtract A over both sides. I have 6K over P minus A equals negative B. Okay, let me erase some stuff here. Okay, so now from here, the last step would be to divide out by a negative. The b would be negative 6k over p plus a. All right, so let's check and see if these both come out to the same thing. They do. So either one of those methods works, whichever way you think about it. Okay, let me clear this out. Let's look at number 40. So for number 40, we're going to learn a bit about cross multiplying. This is called proportion. Now, proportion is a ratio set equal to another ratio. A ratio compares two quantities, so A and B. And the way that you would say on different types of ratios, there's three ways. A divided by B, A to B, or oh yeah, this one. Okay, so A divide B, A to B, or just A to B. All those are different types of ratios. So quick example, Billy drives 65 miles in 3 hours. Make a ratio of Billy's speed. So for this one, essentially your ratio, you'd have miles per hour for his speed. Remember, speed's a rate. So 65 miles per 3 hours would be his speed ratio. Okay. All right, so a proportion is when you have one ratio set equal to a second ratio. Okay. So we're going to set, equal, and solve. Let me clear this out. Okay. So I have negative 9 over x equaling negative 24 over x minus 5. Okay, it's going to help you when you see a factor like this, x minus 5, to put parentheses around it. So you remember it needs to go together. Wherever it goes together. So cross multiplication. Okay, essentially if I have A over B equals C over D, that's ratio equals ratio, I can cross over. This becomes cross product 1. So cross product 1 is A times D. Cross product 2 is B times C. And you're setting those cross products equal to each other and solving for whichever unknown you need. Okay, so in this case up here, we're going to take -9 and multiply that to x minus 5. And we're going to set that equal to x times -24. Okay, so we have on the right side, let's clean this up so you don't think that there's some kind of weird distribution here. Like there's nothing in front of the negative. So it's -24x. On this side, we can distribute. It's -9x plus 45. Get all your x terms one side. And then divide to get the x by itself. Oh, we have x equals -3. Don't forget to check. In this one, it checks out. Save. All right, let me clear this out. I'm going to leave number 41 for you guys to try. And then we get to the word problems and we'll be done with this. Okay, 42. Yes. Tammy runs 7 miles in 50 minutes. At the same rate, how many miles would she run in 75 minutes? Okay, so let me do a new share here so we have more room. Okay, so Tammy, this is number 42. Run 7 miles in 50 minutes at the same rate. How many miles would she run in 75 minutes? Okay, so first off, let's look at the unknown here. How many miles? So X will be the miles she runs in 75 minutes. Okay, now the rate. The rate that we have here is 7 miles per 50 minutes. Okay. We want same rate. So that means set up a proportion. Okay. So let's think about the rate in 50 minutes. We have this one, okay? That's gonna be 7 miles per 50 minutes. Now over here, what will the other rate be? Well, we wanna know how many miles in 75 minutes. So X will be right here. And it should come out with units miles. Okay. So now we're gonna cross multiply. We get 50x equals 7 times 75. Units should work out. The units here would be minutes. Units here, miles. Units here, miles and minutes. Okay. So we have 50x equals 525. Divide by 50, both sides. X equals 10.5. And that should be miles. Check back in your equation, of course, just to make sure that it's correct, following the chapter 5 prompt of checking all your solutions from equations. But do note, if you set this up incorrectly in any kind of way, you will get the wrong answer and it will check out when you plug it back into your equation that's not right. So just be careful with your setup. Okay, that's good for this one. Let me go ahead and go back. Okay, to number 43. Working together, 2 pumps can drain a certain pool in 6 hours. If it takes the older pump 14 hours to drain the pool by itself, how long will it take the newer pump to drain the pool on its own? Do not do any rounding. So for this one, let me give a little background on this page first. These are work rate problems. And the equation that we're going to be using for that, the formula, it's going to be x divided by a plus x divided by b equals 1. X is the time for both objects to complete one job. A is the time for object A to complete one job. And B is the time for object B to complete one job. Okay. So it's kind of a strange formula, I know. It's weird because essentially we're saying that this is the percentage of a job covered by object A. And this is the percentage of the job covered by object B. Okay, And then that all totals up to one total job. Okay. Now, of course, I know that these are like decimal percentages. Well, the decimal version of the percentage is what I want to say. So, like, say 50% of the job is covered by object A and 50% is covered by B. Well, you would have the decimal forms for that 0.5. Half of the job is covered by the first object, and then the other half of the job is covered by the second object. So total, that gives me one full job completed. Okay, so kind of weird, but work with me on this. Work, no pun intended, hee hee. Okay, let me clear this out. And then let's go to our whiteboard so we have some extra room. Come on. There we go. Clear. Okay, so this is number 43. So two pumps together drain a pool in 6 hours. Okay. And then the older pump takes 14 hours to drain pool alone. And we want to find how long the new pump drains the pool alone. So, of course, as you can probably guess, this question mark is going to become X. And X will be in hours. Okay, so let's start with our formula. We have X divided by A plus X divided by B equals 1. Okay, this is, I guess, where it's going to be a little strange. I should call this, let me leave this as question mark, actually. Sorry about that. The reason I'm going to do that is because remember our formula, we already had an X in it. So I don't want you to think that this necessarily is the same X. Remember that the X that's given here is the time for both pumps together. To drain the pool, because that's the one job. Do we have that? Yes. In this case, X is equal to 6 hours. Okay, so where you see X here, we're going to replace that with 6. And then, of course, the 1 part is going to stay the same. That 1 represents one job. And then remember A was the time for one of the objects to complete one job alone. So that could be the older pump. So A is 14 hours. So we're gonna put 14 in A spot. And then that gives us the hint for what question mark should be. B, time for the new pump to complete job online, sorry, a job alone. So B in this case is actually the question mark. So we're just gonna leave it as B. Solve for B. Now, this is all you'd really need to show, and I think Alex does it a little bit differently, so you can use that method if you prefer as well. Let me go ahead and clear this out. Okay. So now we're ready to solve for B. So go ahead and get your LCD. That's going to be 14B. Multiply your entire equation by 14B. Okay, so 14 cancels 14 in the first bit. We're left with 6B. B cancels B, we're left with 6 times 14. And then finally, 1 times 14B is 14B. Okay, so go ahead and solve for B. We have 6 times 14. That is a number value. And still have 6B out here. And then we have a 14B over here. Come on, man. Okay, get all your B terms to one side. So 84 equals 8B, which is 10.5. And the units, how long was in the question? Remember, unit should be hours. Save that. Okay. Let me go back here. Let me start with number 45 because it's a little bit shorter. And it's probably not something that I'm planning on asking for your actual quizzes and exams. So write an equation that expresses the following relationship. Um, W varies jointly with U and D and inversely with P. In your equation, use K as the constant of proportionality. So for this part, this is so basically being inversely or directly proportional. So let's say direct over here and indirect. Okay, so what we're going to be comparing, we're going to have two oh gosh, what am I thinking? One second. All right, sorry about that. It's taking me a minute for remembering this word. But we're going to have two quantities that are related by a proportionality constant. Okay. Okay, so here's your first one. For direct proportionality, that is also referred to as jointly proportional. So y will equal k times x. And essentially, as y increases, as x increases, y increases. And then indirect or inversely, okay, so as x increases, y decreases. Okay. Okay, now there's a really simple way to do this. Okay, W varies jointly with U and D and inversely with P. And then you have your proportionality constant. Okay, so essentially put your first quantity, the W, and then for things that vary jointly with it, just put those letters on top, and inversely put those letters on the bottom, and then put a K between. Okay. Definitely review on Alex. I kind of just sped through it, but it's because I'm not going to ask you anything specific on it later. A more important question is number 44, which will take us to the end of this. Okay, so number 44 A plane has a cruising speed of 200 miles per hour when there is no wind. At this speed, the plane flew 500 miles with the wind, and in the same amount of time, it flew 300 miles against the wind. Find the speed of the wind. Okay, so I would suggest having this paper in front of you so that when I go to the whiteboard, you'll be able to follow along. This is number 44. Okay, I already know I'm gonna need some more space. Okay. So we are gonna have a distance rate timetable here. And we have this plane cruising at a speed of 200 miles per hour with no wind. Okay, so he flies 500 miles per hour. Sorry. The plane flew 500 miles with the wind in the same amount of time as flying 300 miles against the wind. Okay, and what we're looking for, the speed of the wind. Okay, so let's fill in what we know. One of these situations will be the plane with wind, and the other will be the plane against the wind. For chapter 5, fill in time, spots, last. Remember in chapter 1, it was actually distance we filled out last. We got our rates, we got our times, and then we multiplied them. For this, essentially, distance equals rate times time. We're going to be using time equals distance over rate. So do we know the distance that was traveled? In both cases, yes. 500 miles and 300 miles. Okay. Do we know the rates? Well, we know that the plane speed is 200 miles per hour. And we know that with the wind, he'll get the help of the wind speed, and against the wind will work against him. Okay. And then finally from here, this is when we get our times with respect to x. So that's going to be 500 divided by 200 plus x for with wind, and against wind will be 300 divided by 200 minus x. Now we have the time with the wind being the same as the time against the wind. So time with wind, 500 over 200 plus x. Against the wind, 300 over 200 minus x. All right, I'm gonna do this a little bit quickly. 500 times this quantity. It's gonna be equal, oops, to 300 times this quantity. Distribute. And then combine like terms. And we arrive at X. All right, that completes this bit. Let me know if you have any questions, and I will check in with you guys a little bit later this week.